Hello, good morning. Today we're going to discuss data collection and presentation. We're now going to have the data gathering strategy for majority of engineering applications, which is the experimental and control groups. The main component of the experimental and control groups is the experimentation or the treatment and the groupings of the samples. An experimental group is a group that receives an experimental procedure or a test sample. While on the other hand, a control group is a group separated from the rest of the experiment such that the independent variable being tested cannot influence the results. This isolates the independent variable's effect on the experiment and can help rule out the alternate explanations of the experimental results. So basically for experimental and control groups, we will be having two groups. One is having no treatment or somewhat having a placebo. A placebo is the treatment that you give to a group which does not really have an effect to the respondents. While the other group or groups are the experimental groups receiving various treatments. There are different experimental research design. The first is the pre-experimental research design. So for the pre-experimental research design, we have the one-shot case study. We have the one group pre-test to post-test design and the intact group comparison at post-test or the static comparison. So for the one-shot case study, this is the treatment group only. So what you do is to perform the observation after the treatment. So what you're going to do is to apply treatment, X is the treatment. So you apply the treatment and after ending the treatment, you do the observation. So that is one-shot case study design. Example, X is a new personal policy. A job satisfaction measurement is taken and then a response is observed. The second one is the one group pre-test and post-test design. So what you do is to perform observation at the start. You apply the treatment and then you observe what happens. So an example is a job satisfaction measurement is taken before and after the treatment X is applied. So for example, you measure their current happiness. So you have a questionnaire about happiness. And then after that, you apply the treatment unknowingly. So you perform a treatment. So say for example, you play music at the workstation every day. And then after that, you check their happiness um, at the workspace. So that would be a pre-test, post-test design. So currently there's no music. So what you're going to do is to observe their behavior. And then what you're going to do next is to apply a treatment. So you apply music at their workstation, and then at the end, observe what happens if you're going to after applying the music. Next would be the intact group comparison at the post-test. So you divide the group into a control and experimental, and then one group receives a treatment and the other one would serve as the control group. So what you're going to do is to observe both of them at the end of the experiment. So group 1 receives a treatment, group 2 does not. Then a job satisfaction measurement is taken and observed um, at the end. The study does not include pre-testing, and therefore any differences between the two groups prior to the study are unknown. So it is possible that group 1 is really better than group 2, and then you apply the treatment, and then at the end, um, the group so the factor really is not based on X or on the treatment alone. It is possible that group 1 is really better than group 2. So this is um, this assumes that group 1 and group 2 are um, homogeneous. However, that is not always the case. So there is a possible loophole in this design. Next is the experimental research design. When you say experimental research design, the main characteristic of experimental research design is the elements of the treatment and the control group is randomly assigned. So you randomly select elements that would go under treatment group and control group. So we have three. We have the post-test only control group. We have the pre-test post-test control group and the factorial analysis. So for the post-test only control group, so you divide the population into a control group and the experimental group. So group 1 and group 2, and there would be randomization between group 1 and group 2. You select who would go under group 1 and who would go under group 2. The group that would receive the treatment would be the experimental group, and you have a group that does not contain the treatment, so this is the control group, and then you perform observation at the end. Next would be the pre-test and post-test control group. So there is an observation at the start. So after that, you randomly assign which one would go under the experimental versus the control group. So they should have the same characteristics, the control group and the experimental group. And then after the treatment, you observe their difference. So the main difference is now brought about by the treatment. While the factorial design, you have first group, group 1 versus group 2. So what you're going to do is to divide them or identify various factors, various questions or various constructs, and then check the construct 1 or the variable 1 versus check the first variable in terms of the control group and the experimental group. So same is true with the others. So you observe that at the end of the experiment. The next type of experimental design is the ex post facto design. This means that the statistical controls for comparing the treatment and the control relationships between the two variables called ex facto or ex post facto because the researcher arrives after the treatment has been administered. So we have the correlational design. You have observed it already. There is the observation already, observation 1 and observation 2. So you're just going to compare the two after. We have also the criterion group design. So based on the criteria, you compare group 1 and group 2 on the data that you have collected.